Welcome to the world of SimonsVoss digital locking systems. Today, I want to show you what options a networked digital locking system offers and how you can set up a network in just a few steps. Digital locking systems on their own already offer a wide range of possibilities to adapt your locking devices to your needs. A networked system will provide you with a full range of functions and maximum convenience. What do we mean by a networked locking system? First, let's look at how an offline system works. Here I have a programming device, which allows me to make changes to authorizations in locking devices quickly and easily. Once the locking device is installed, I obviously need to go to the door to make any changes to the programming or read the locking device. However, if I have networked the locking device, I can perform all programming tasks conveniently from my workstation via the router. The router then transmits all information to the network cover. I can retrofit this cover at any time. I can thus start off with an offline system and then network my locking devices as I wish at a later date. A networked system is always the best choice if you want to program locking devices quickly and easily, if there are events which your locking system needs to respond to, or if entire areas need to be placed in a specific mode instantly. The routers form the heart of a networked locking system. They allow me to do much more than carrying out programming tasks and reading locking devices. The I/O connections provide me with 3 inputs and 3 outputs. I can use the inputs to engage, disengage, or deactivate all locking devices in the router's environment. I connect the outputs for authorized or unauthorized ID media and to activate systems or devices in my building as I wish. I will now show you, step by step, how you can connect your locking devices. First of all, I mount the lock nodes onto the locking devices. Lock nodes act as network adapters and establish the connection between the locking device and the router. I simply plug the lock node into the circuit board in the smart relay. Obviously, ensure that you have disconnected everything from the mains while you do this. On the cylinder, I merely need to replace what I call the offline cover with a network cover. I then connect the router into my network. This means that I assign an IP address to the router where I can contact it. To do so, I connect the router with a network cable and launch the OAM tool. You can download the software from the SimonsVoss homepage free of charge. The default address for the router is 192.168.100.100. As soon as the router is displayed, I right-click on the entry with the mouse and select Set IP. I then uncheck the Enable DHCP box and change the IP address. I now no longer need the OAM tool. It's now time to launch the LSM software and configure the network. I have already prepared a small locking plan here. A cylinder, a smart relay, a transponder which is authorized for use on both locking devices, and one which does not have any authorizations. First of all, I create a network plan with the router and the two locking devices. To do so, I launch WaveNet Manager, which is available on the SimonsVoss homepage, just like the OAM tool. In the first line, I indicate the WaveNet Manager.exe file. In the second, I indicate where the output file should be saved. This is where the information on the network components are written. Ensure that you have right access for this folder. In the next step, I can issue a network password. This is beneficial if a number of networks are operated in proximity to one another and you wish to prevent any unintentional programming of other devices. I add the Ip Rueter in the WaveNet Manager. Right-click on the WaveNet_8_8 entry and add IP or USB router, and then OK. As I'd like to add an IP router, I select IP address and enter the address which I have issued on the OAM tool. I click on OK to confirm. I can see my network ID in Network Options. I can change it if I want to. I can adjust the radio frequency. But why would I want to change it? If I have another network in close proximity, I select another frequency and thus avoid any interference. In some regions, I need to select an approved frequency. Next, I select how many locking devices I'd like to address with the router on the network mask. In the 8_8 mask, I can connect 249 routers to 249 locking devices. In the 11_5 mask, 1,790 routers can each be linked to 25 locking devices. The 12_4 allows me to link 3,200 routers to 9 locking devices each. In my example, I select the 8_8 mask, confirm by accepting OK, and can then see my router in WaveNet Manager. In the next step, I link my locking devices, meaning my cylinder and my SmartRelay, with the router. I right-click on the router and select Search by Chip ID. I can find the chip ID on the packaging for the network adapter concerned. I then look for the cylinder's network cover. I enter the chip ID and click on Start. If the chip ID is found, I highlight the router. Press OK to confirm and see the lock node in WaveNet Manager. I set up the network adapter for my SmartRelay in the same way. Right-click on the router. Search by chip ID. Enter ID. Highlight router. And then I have now quickly incorporated the second component. I now tell the router how it should behave. Right-click on the router again. This time I select I/O configuration. In the case of the outputs, I determine what events the router should respond to authorized ID media, to unauthorized ID media, to both authorized and unauthorized ID media, to input feedback signals. In the case of authorized ID media, specific building systems would be activated, for example, such as the air conditioning system or lighting. In the case of unauthorized access attempts, I would turn on a camera or a warning light. I select Input Feedback Signals if I'd like to receive feedback signals indicating that all the router's locking devices have been reached and all receive a signal to engage, for example. Output 1 needs to activate my warning light as I wish to receive a warning message if an unauthorized transponder tries to open a door. I thus connect the warning light to the router. Pin assignment starts at the outputs at the bottom and continues with the inputs above. The outputs are connected for 0.2 seconds. I use a time module for my light and let the light flash for 10 seconds. I place all the locking devices in the routers section in a selected mode on the input side. If I select Block Lock, all locking devices are deactivated and can no longer be opened until deactivation is disabled. This function is ideal in combination with an alarm system if doors may only be opened if the alarm system is disarmed. The anti-gunman attack function deactivates all locking devices and remains active until the anti-gunman attack function is disarmed again. The emergency release allows locking devices to be permanently engaged to open. I would use this function in combination with a fire alarm system, or also for a company open day if I did not want to go from door to door individually to open each one. Remote opening offers me a similar function to emergency release. In this case, the locking devices engage to open before disengaging again as for normal access. In my example, I select emergency release for input 1 and remote opening for input 2. This means that the locking devices disengage again once the alarm status has ended. I only need a delay if I need to wait for another system. What do the corresponding connections on the router look like? Here, input 1 for the emergency release and input 2 for remote opening. I leave the two boxes checked because I want to address both locking devices. I confirm everything by generating the protocol for my system and using my locking system password. The new configuration is now transmitted to the components. Save. Finish. And import. When I press the button now, Input 1 is connected to my router, and my locking devices receive the signal to engage. If I release the button again, because the alarm has been eliminated, the locking devices disengage again. If I use the unauthorized transponder on a locking device, output 1 activates and my warning light starts flashing. I now assign the lock nodes in the locking devices as well, so that I can also conveniently program them using the router. The quickest way is to use a collective task. Network collective tasks. WaveNet nodes. This is where I select Configure Automatically, and the locking devices connect with the lock nodes. If I now change an authorization, they are programmed instantly via the router. My network is now set up, and I can take full advantage of a networked locking system.